Hello, first-time coders. Today we want to learn how to solve problems using coding. Any problem can be broken into three components: input, processing, and output. For example, let's say you went to a coffee shop. You gave your money to the barista and you tell him the type of coffee you wanted. This is an input. Barista starts processing your favorite beverage. After a few minutes, he hands you your nice warm beverage. This is the output. Input is the raw material required by the system. So we give the system an input in an expectation to get an output. An output is the required product or the desired product we need from the system. Processing is the act of transforming or converting the input to an output. For example, in football, you give the players the football, the coach, the stadium, and so on. The process is the game. In the end, what we want to know is the score. Eating. We give food as the input, we digest the food, and we get energy as the output. However, good coding requires strategy or a game plan. This is known as an algorithm. You can write an algorithm using many tools, such as UML, state diagram, flowchart, or pseudocode. For simplicity, we'll be using pseudocode in this series. A pseudocode is a plain language description of the steps in an algorithm. I believe you have been using pseudocode without even knowing it. I am sure at some point in your life you have sent someone a WhatsApp message, an SMS, or an email describing how to do something. For example, yesterday my wife sent me a WhatsApp message explaining how to cook a pumpkin stew. Notice how the first message is about the ingredients. These are the things I need to have available in the kitchen before I even start making the stew. These are our input. Then she continued with the steps. The subsequent messages are about the steps and they are in a chronological order. What I should first do, second, and third. So you can see that this is the process. Finally, when all this is done, I am going to end up with a delicious pumpkin stew as my output. Let's try our hands on an actual coding example. Let's say we are asked to calculate the distance covered by a golf ball after it's hit. Let's say we know the initial velocity and the angle at which the ball is launched. So, based on our experience with physics, we know that we should be using the projectile equation. We know that the projectile equation is the range or the distance covered by the ball is equal to u square times sine 2 theta all over g. So from the question we know that we are expected to find the distance covered. So this is our output, right? And we know that we know the initial velocity, so this is an input, and we know the angle, this is also an input, and we know the gravity, the acceleration due to gravity also. So let's write our pseudocode. So our pseudocode will start with the ingredients: input u, theta, and g. Our output is expected to be range. So steps. Our first step is to ask the user to enter u, theta, and g. Then the next thing we can do is to use the equation u square sine 2 theta all over g, and then finally we present the output to the user by printing r. So there we go. Let's try another example. Let's say we are asked to calculate the time taken for an object, let's say a football, to travel from point A to B. If we know the distance from A to B to be s, and we know the initial velocity of the object, u, and we know the acceleration of the object, a. So from this, we know that the best equation to use is u is equal to ut plus 1 over 2 at squared. Okay? So, but in this case, we are asked to find time. So time is our output. Therefore, time should be at the left-hand side of the equation. So let's solve for the equation. If we convert this equation to a quadratic equation, we will have something like a 1 over 2 at squared plus ut minus s is equal to 0. Now our equation looks like a of x squared plus b of x plus c is equal to 0. So we know that s is this, b is this, and a is this. So we know the solution for the quadratic equation can be solved with the formula x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. So if we use this equation, we can say, okay, t is, we know that b is u, so t is minus u plus or minus square root of u square minus a is 1 over 2, so 4 1 over 2a, and c is s minus s, sorry, all over 2a, all over 2 times 1 over 2a. So if we simplify this, we will have something like this. this 2 will get this to 2, and then we have a simpler solution as t is equals to minus u plus or minus square root of u square minus 2 plus 2as, because of this minus here will affect this minus, all over a. So we can just write our algorithm as we have the input to be initial velocity, distance, and acceleration. And we know the output should be time. So we can ask the user to enter initial velocity, distance, and acceleration, and then we use t equal to we use t equal to minus u plus or minus square root of u square minus plus 2as all over a to get the time, and then finally we print the time t. So this is our output. Thank you for watching and see you next time.